Good morning, everyone. Um, I know many of you have a hangover, and I mean, if you guys are in this room at 10 a.m. on Sunday, you're like real heroes. So, I mean, let's applaud each other and warm up before, the whole conference day. And yeah, so I'm gonna start telling my story. All right, so this is based on a true story of a young programmer that had to change his beliefs in order to do some real software engineering these days. So I'm doing mostly DevOps, which is pretty much means that I'm doing infrastructure programming. And this is quite exciting because you get to connect, different computer systems with each other and see how they interact and build them on a scale from like 10 machines to 1,000, and this is pretty exciting. And I started using Python, which is, an awesome language. And PyCon as a conference is a pretty great place where, everybody speaks pretty much about anything about Python. Because, 2 years ago, everybody was keen on databases. The year after that, everybody was speaking about, DevOps, basically. And now this year, everybody speaks about machine learning, and Python is just in the background of all of this stuff because people here are really doing amazing things, and running startups, starting their own companies that do robots and shit. So this is pretty much unlike any other exotic language conferences where people just talk about adopting their languages. So PyCon is really cool about that. So let's, step back and reflect about, how we all started with Python, or some of you started. And you probably remember this. This is the thing that excited many girls yesterday. It excited me like 4 years ago because, I've just seen HTML pages and, they were just ugly. And then somebody told me about this language, which is in C. And it, it didn't have brackets in it. And if you download this thing and type Django admin startup my site and then something managed by run server, you get to see this. And when I saw this, I realized that if I used Django, I would have had made great websites because the welcome page looks slick. And all of your websites with Django look cool by default. Well, I was wrong, because Django held these ugly things like ORM, which hid the real shit that happened in the computer science behind these nice Python objects. But it's still Django is cool because it gets you from zero to web app in minutes, and this is pretty exciting. You can build this dashboards and stuff like complex web apps for different embedded systems. When you build them in Django, later you realize that Django is too fat, and you move away to some micro framework, and you go like build some crazy validation stuff, like do boring forms. Then you realize that if you hack on anything but web applications, Python is also nice. And my switch went out. All right, it works. So. And you get to use Python for just about anything, like interactive hacking on system apps. You use it for all kinds of crazy stuff, like avoiding C++, just because you can use Python to wrap ugly C++ code, or just generate bindings and use them, and you have a nice language. And you get to do scientific computing, machine learning, you get to do desktop applications, and if you ship your desktop application, you get to ship code with it. But who cares, because just Python is just so nice language that you just do that. You do system hacking, you do automation scripts and whatnot. So Python is so awesome, why would I even look elsewhere? But as as any young engineer, you just need a challenge, first and foremost. And now I'm gonna explain my motivation. Why would I ever look away from Python? So you know, happy November. You know, who doesn't know what November is? So, okay, so this is the thing where you don't get to shave for the whole month in November to raise awareness for men's health issues. So yeah, I started participating in it, and I haven't shaved since this morning. And it's been, you know, like almost 2 hours. But most of us, we take shaving for granted, you know? You can just go to the store and, you know, buy shavers with lots of different blades. You get like 5, you get DualShock and, you know, Xbox One shave blades. And if you look at the history, you know, shaving was hard. You got to hire a separate person with immense skills, you know. He was doing that with a knife, and you were trusting him enough so he doesn't cut you or, you know, kill you in your sleep or while he was shaving you and everybody is looking. And now, just everybody just gets a blade and gets it done himself. So in some way, we can say that shaving is now democratized. And, you know, thank you, Eric Meyer. I stole this idea of speaking about democratization from his talk. So thank you again. If you're watching me, please don't blame me. So democratization is a process of a good or service to get wider audience over time. You know, like Python was written by one guy, and now like 300 people in the room are using it. So the thing gets widespread. Like think about, think about education. You know, earlier education was just available to noblemen, and you had to be really rich to get education. You had a special tutor that was only available. He was solely dedicated to you for the whole time of your, you know, education. He was so smart, and then you would get this knowledge and pass it through. And then it became adapted to a wider audience. You started to be able to go to the university, where you usually sit in a crowd like this one and listen to a single person speak and you know, import wisdom into you. And it also means that if there are lots of people in the room, there are too many distractions, and the quality kind of went down of the education. And now you can just, you know, get a MacBook and join Coursera or Udacity or whatever and just get education for yourself without even attending anything. This kind of reminds me of myself because I was kicked out of the university twice, and oh, there's no computers there. Okay, so here's the slide that you missed. This is only a 13-inch MacBook. If everybody has somebody 15-inch, I can make it bigger. All right, computers work. So, have you seen this and this? And probably I will stop at this point. So, you know, noblemen, universities, and MacBooks. And pretty much you can now use MacBooks not just for wasting time, but, you know, for spending it with, you know, oh, the video has interrupted. And so the same stuff happens with food. You know, back in the days, like, you know, 1800s or something, you get to go hunting and, you know, kill animals. Now we build robots to kill animals, but we used to do it, well, our ancestors used to do it themselves to get food Then they learned to grow it, and now you have this thing of, a supermarket, if you just need a gallon of milk, you go there, you get a gallon of milk, and you can just think of a supermarket as a infinitely sized pantry that you rent. And you think of it just of, an extension of your kitchen. You can just go there and get what you need. So, but you don't need to think about hunting or, growing stuff. You just go and give them nodes or insert cards into some special box and just get your food. So another part of democratization is my stupid presenter. Is abstraction, which is pretty much means that you ignore irrelevant details and hide them from your customers that use your good or service. And it also means that old skills become impediment in the new world. Like, you don't need to do hunting anymore. You just need to know how to reach your pocket and get a note from it. And this also means that you don't have to attach to old traditions. So you have to change the way you work about, the process of getting food or providing any other kind of service. Like, consider transportation. To get from point A to point B in a steam train, you had to employ a special human throwing coal into a big burning hole. And I don't even know what it's about, right? Because now we have this cool slick cars that, we have this simple interface of, a wheel, a pedals, and a gear stick, and who knows what kind of, internal combustion engine works in it, because we don't care. It was abstracted away from us like more than 100 years ago by some cool people. And we just take, it for granted. Now, let's talk about computers. Who doesn't remember the fail whale? Everybody does, because computers crash all the time. It's all because of us. Because, we are too lazy and we get distracted easily and we write shitty code. And this happens all over in, cloud computing. And, computing was also democratized because we used to, operate these huge machines that took up the whole room. And now we just can rent an infinite number of computing and storage power, and we have to do distributed systems that harness that power and makes it do the things we want and makes it do business on it. And old skills again become impediment because yesterday we had sysadmins, network admins, database admins, and now we just replace them with software. And those guys need to, change their skill set to become, guys like infrastructure programmers or, DevOps. Because they don't have to do the boring stuff they used to do anymore. And the same stuff goes with programming, right? This code probably doesn't make sense, but it is probably Python that would build. And, Python is still pretty much 1950s era tools, because if you look at the code, you see like state, you see destructive assignment, you write code everywhere that does side effects, that just, if you see a single function, you don't know what it does, you can think that it can rape your fridge and, bite your dog. And this is just about sequential composition. You write code from top to down and it gets executed from top to down. And you get to do these ugly old flowcharts. And so pretty much Python is 1950s era tools. And you could probably get better at it, at writing programs. And I started suspecting something. So you see, stuff that you've seen at this code from top to down takes a different amount of time at every line. Like a line at the top runs very fast. It just, binds one to a name A in your local scope. The second line takes a lot more time because it has to allocate space for a hash table. And the second one has to open a file. This means it has to contact the library that does, operating system stuff. And it has to allocate some resources for your file. Look it up on disk, and then, start spamming the disk, and, it takes time, and then you get a thing from a URL, which is doing an HTTP request, which, in terms of human time, it takes ages, which is greatly represented on this table, which says if you map scale computer things to human time, like one CPU cycle takes, if you imagine that one CPU cycle takes 1 human second, then, talking from San Francisco to Australia takes 19 years. And we still write programs that assume that, saying request get from URL takes the same time as, assigning one to A. So, writing programs that assume that stuff taking time can no longer be implicit. This in the new world when you do clouds and shit. And, Python tries really hard to keep, with time, to keep up with the research, to keep up with the reality, and tries to, change the things that you do in your language. So you still write code from top to down, but it assumes all kinds of crazy things, like you can thread this code with the same function with this code using some different heuristics, basically. And around the time I realized that Python 3 was starting to be popular, and Python 3 broke everything, like my code, so I became bored with it and I walked away. The journey begins. So, I find this nice movie on the internet that said, like, hello Mike, hello Joe, is the system working? Yes, seems to be. Okay, fine, bye-bye then. This was a pretty boring video. The two guys talking on the phone, what can be exciting about that? Then I realized that the exciting system they were talking about was Erlang, and they were talking about it like 40 years ago, probably 30 years ago. And they were trying to create a programming model for telecom, which pretty much maps to what the things we do right now. We program highly loaded systems that exchange messages, which is pretty much every HTTP website that does real-time stuff. So Erlang was like a huge paradigm shift to me. Instead of thinking about mathematical stuff, about computation, you get to think about physical entities of your computation. Like if you think about interacting with some client, you spawn a process. And if there is a system that does database stuff, you spawn another process because it's a single physical entity. And you exchange messages, and this was like shit crazy. Because I used to do this in Python using 0MQ, but turns out it's a lot new crazy stuff in Erlang. And you also get an operating system for your language, which is pretty cool, and it changed the way you think about programs. But Erlang deserves a whole lot another talk, and there are lots of other conferences on Erlang. So I also was too excited about it, and then I saw this nice thing. It was called Haskell, and a bunch of crazy characters to write programs. And I heard this rumor that you had to know advanced calculus to write a hello world. So I began Googling more, and I found this. And if you Google Haskell, you see this guy. So probably Haskell is really cool. Because, slick guys do Haskell, but turns out that his name was just Haskell, and he's a cool, famous, British rugby guy. And if you Google Python, you get this. Which is, guy bashing his hands against bricks. And this is what you get when you Google Python. So if you see this for Haskell and see that for Python, the language must be pretty cool, right? So Haskell is all about pretty crazy shit. You get pure functions, which doesn't mean your program can rape your fridge anymore. You get combinators, which are pretty much functions that do not depend on global state and variables, and you can combine them with other functions, which is pretty cool. You don't say import anti-gravity and your electricity goes down. Like you can't just do a thing and then figure out that something happens. There's a whole, railroad things saving you from that. Higher order functions, pattern matching, algebraic data types, persistent data structures. Everybody's crazy about them right now because it turns out in the modern world of parallel and concurrent programming, these things really matter because they help you reason about programs differently and help define cool algorithms that mangle the code in a proper way so it does the job you want faster. Haskell turned out to be really crazy because it does lazy evaluation. And when you write code from top to down, you usually expect these things to happen from top to down. And in Haskell, your programming flow doesn't depend on the source code organization anymore. And it's dependent on the order of execution, of the order of evaluation of your programs in the call order, which is pretty cool. And you get to learn about this thing called S2G machine, which is called spineless, tagless G machine. And I used to not know what it meant, but when I read the paper, it turned out to be pretty cool. And this is how the language works. And everybody talks about this thing called category theory. And it's pretty much about reasoning how to compose different things. And in Haskell, this is a real religion about organizing your code, because you write programs using these primitives called functors, semigroups, monoids, applicatives, monads, and they really help you to reason about your code differently. And if you use these mathematical things, they have already proof attached to the properties that they hold, not just blog posts on the internet, like saying JavaScript is cool, we just invented this pattern and that pattern. But in Haskell, a lot of guys wasted lots of their time to prove that these primitives actually do what they say. And if you organize your source code in the way in the categorical way, you get a bunch of cool stuff for free, like composition and stuff. So this comment really touched my heart when I saw it on a cool blog, Haskell for All, which pretty much sells a lot of introductory cool stuff about category theory applied to Haskell development. And this thing, in Haskell, there's a thing called type checker, which, verifies that if you say apple and then try to, add it to an orange, it won't let you to add an apple to an orange. But it's not that simple, because you can do it in C or in Java. But you have this Martin-Love type system, and there is a bunch of papers reading about it that you can express really complex types and dependencies in your program. Like, I'm a DevOps, why would I need a type checker? Turns out I do. Because, as a programmer, you get to just take different Lego parts and assemble them with each other. And that's how we build software. We get someone's work and then attach it to some other work and, build really cool stuff. You can build Death Stars crap with it, Lego is so cool that you take this tiny part and, assemble huge objects, huge complex systems about. And, who remembers this Soviet Union type constructor, mechanic? Yeah! Right, my parents gave me it for New Year. And I was so disappointed because everybody, had Lego. And I had this thing where, with Lego, you can build Death Stars. And with the Soviet thing, you can build a bicycle. Right. But you see, as programmers, we get to work with these really shitty systems. Like you have to, if you work in an outsourcing company, and a customer comes to you and says, hey, you guys, so we need this Death Star type of thing, but you have to make it be on a bicycle all the time. Like a Death Star, an object that is flying in space on a bicycle, that's pretty stupid. So you get to write glue. Like infrastructure programmers write glue all the time. They try to, map a Death Star on top of a bicycle. And these are different systems that were made of different components. And this sort of an impedance mismatch. If you just choose a single technology for the rest of your life, you get to build a system from a set of, alike components that compose pretty well with each other. But if you get to match systems with different impedance, you will have to need a type checker, because this is a cool program that tells you when you're wrong before you compile your program. And nobody has been fired for a compilation time error, but you can lose millions of dollars with a null pointer exception. So probably type checker is worth looking at. So when I speak about glue, you use these stringly typed languages when you have a single type and it's a string, which is, an example of the language is a shell. And if you have a type checker and you can express your code dependencies in it, you get a nice glue gun, which is Haskell. So I had this thing, I was doing some data mining at the company I entered. So as I'm doing infrastructure, I had to learn what the infrastructure is about and figure out what's going on. So I started writing some shell scripts. Well, I was actually using make, because make lets reorder shell scripts in a Prolog-like way, but I was using lots of awk, and sed, and cat, and grep at the time, and I wrote a bunch of code that was used to map different commands across Linux machines, and then process their output and draw graphs. But next day I woke up, I couldn't even figure out what was going on in that code, because it's messy shit. And in Haskell you can just specify types. For example, you try to match connections on different machines. You just say there are new types that bind strings to rename strings, like create a nominal name for another type, and basically doesn't let you, misuse it. And create these algebraic data types that you can better match in runtime and stuff like that. And then I went to building, a new infrastructure automation tool. So we were using Nix in our company, the thing that Domen told you yesterday about. We use it to build basically machine images with it. And we need to get it somehow into the cloud, and it's about evaluating a domain-specific language that described the set of AWS resources. And I had to translate this language into a set of AWS API calls and create that infrastructure. So Haskell really enables you DSL-driven development, because if you do DSLs, you can get different strategies for evaluation of that code. And if you do, for example, infrastructure automation, and you screw up with misusing API calls, your company gets to spend money, because if you launch 1,000 of machines, it kind of feels, it pretty much equals your salary, the thing that you, by programming errors, found accidentally 1,000 of expensive machines in the cloud. And I've done that once, and I don't want to do it again anymore. Yeah, so that's why I do Haskell partially. You get this rich, massive programming facilities, like free applicatives and free monads. You just go and read what they mean. They're pretty cool. You get quasi-quoting. You can define your own parsers inside the code. So, you know, if you remember the thing where you used to write PHP code inside with SQL, HTML, and CSS in the same file, you can do it in Haskell, but in a free type-safe way. You get template Haskell, you get generics, all that stuff, and a library that takes it to extreme is Haskell, which is a library written by Facebook guys. You know, in Haskell community, it's good to say that I want to be Zuckerberg. Why? Because now I can hire Simon Merlo to work for me. And you know, Simon Merlo is a pretty slick, clever Haskell programmer. So they invented this library that, using free applicatives, let them define a DSL for querying their Facebook graph database. And with these free applicatives, they were just expressing the way the queries look, and they were writing machinery that was create automatic batching, solving the n+1 query problem, solving the concurrency, implicit concurrency stuff, without just, you know, thinking about it, without writing programs top to down. They just write an expression that, you know, expresses declaratively expresses the whole thing, and then they just write a separate code for actually turning this expression into something meaningful. And this gives you pretty cool power at your hands. So you get to testing, you know, you still can test, and if you have types, you probably need to write less tests, because my Python code at the time was pretty much all about writing assertions in the beginning of the functions, writing tests that call a function and then verify that an output is actually has a type of a certain object, which I never have to do again. And this quick check property-based testing, and you can still do TDD if you like, but you won't want it anymore because you have so much different stuff at your hands. Or you can now just, with Haskell, you can just be confident enough to just ship it every day. And you don't have to have it pass all the rounds of QA, manual stuff. And you know, Haskell is also not for doing ops. It does static binaries, pretty much like Go does, except, you know, it's not a shitty language, which is, you know, stuck in the 60s of computer science advancements. So if you want to hack on the runtime system, it's just C code, and it just evaluates the spineless, tagless G machine, which you can simply read and find out what's going on. It has an improved I/O manager in a recent compiler. But if you do ops, you get to do this troubleshooting. You know, you do this profiling by using sampling profilers that get stack traces of running process. It's kind of harder in Haskell because, you know, lazy evaluation doesn't get you to the point where you get normal stack traces. You get them completely differently. But, you know, if you do callbacks in your Python code or JavaScript, you don't get normal stack traces either. So at least in Haskell, this is fun. Right, and community. The Haskell community is awesome. There are a lot of crazy, clever people who read lots of papers. And you can find many ex-Python folks there, because, you know, Mercurial author, one of the Mercurial authors, Brian Sullivan, is actually a guy who does Haskell, and now he works at Facebook, and he's an ex-Python guy and can speak a lot about Python and Haskell, and this is pretty exciting, because, you know, when you come to this foreign community, you get to actually meet a lot of people that think the same way about you, that you do. That they were using Python for a lot of different applied stuff, and now they wanted something more, and they just came there and got it, which is great. You know, with Python, things are easy, and hard things are possible. And with Haskell, hard things are easy, and the impossible has just happened. So this is great. Haskell is different and opens you a new door to new cool things, the ways that you reason about your programs, not just from top-to-down code, but you write, you know, expressions, then you write compilers. I tend to say that, you know, Haskell is a nice framework for writing compilers. And if you think about your program as the data and the compiler that processes your data, this is pretty cool. But Lisp guys have been doing that for 60 years now. But in Haskell, this is really much more fun, believe me. So this is pretty much it. Thanks for watching. Good night. Yeah.
Okay, so who wants to challenge what has been said about Python? And actually,
I'm gonna take my jacket off.
Yeah.
Come on.
Well, as I know, Python is also quite complex language, so different functional stuff could be done in Python, don't you think?
Yeah, I was actually was going to say about that. I think I removed those slides for the reason I don't know. But you see, that's what I did when I first seen Haskell for the first time. I didn't understand the whole thing, and I couldn't produce any working code that wasn't something harder beyond the hello world and the things in the book. I started using map and filter more in my Python code. And then I started to build this, parsing combinators and stuff. And I've seen that, first of all, the language ecosystem doesn't enable you to do that. First. Second, functional programming has a lot more complex ways you specify your code, and if you have to evaluate it in Python, you get to pay a lot more runtime overhead, and you lose performance. But there's actually a nice library in Python that's called fnpy, which is written by our famous friend that talks about Python a lot in Kiev, Alex Kachayev. And he has written lots of proof of concepts of, doing functional stuff in Python. Though this is not really production ready, but it kind of has some potential. But you don't want to put a new car on an old chassis. You just want to buy a new car. So that's the reason.
Okay, any more questions?
Can you tell us a bit about package ecosystem in Haskell?
We use Nix.
And is it as complete as PyPy?
It's way cooler than PyPy. If you use Nix or Python, you get to learn how nice it is.
Can be Haskell used for web backend development? Is there any web frameworks?
Sure. By the way, there are at least 2 popular REST frameworks being released in Haskell in this last year. And there's a cool startup called Silk. I have no idea what they do because they tried to do some interactive Google Docs type of thing, but they do a lot about Haskell and about backend development. If you just Google them, you get to see the stuff, the effort they've put into making web backend development available for everyone.
Thanks for your talk. It's awesome.
Thank you.
The question is, what tools do you use to write Haskell code? Some plugins,
That's it.
editor.
The thing on the screen, that's it. Yeah, I also use Tmux.
I have a question. Who has used Haskell and went back to Python? Who has used Haskell except? So, yeah, you have used Haskell. So, why are you doing here? Are you going to continue using Haskell, or who can tell me? I want to hear that Python is much cooler. Who can say in more detail about this?
And I won't even argue Python is much cooler, except it has been true 10 years ago. Time to change and stuff. And by the way, if you do write Haskell code, you don't have to start a company to write Haskell code. On the contrary, that was said yesterday. You just write Haskell and be happy and stuff.
A big point for Python is that you can earn the money and actually working on the job and coding on Python, but in Haskell you couldn't.
I make money full time for Haskell, so if you want to do,
Haskell?
yes, if you want to do,
you kind of like you know, the special or diamond of, because the vacancies in the Haskell programmers, especially in Ukraine, it's kind of like 3, maybe 2 people or 5 people in the whole Ukraine to work on the full-time Haskell programmist.
yeah, this is true, and this is a problem for the community. But the thing is, you don't get to find a Haskell job on a job website. You go to the community and you learn that there is a sheer amount of jobs available for Haskell. If you really want to do that, you will be doing that, believe me. Yeah, it said DevOps in Haskell, and I was like, oh my motherfucking god, is this really true? And yeah, it turns out it is. Yeah.
What actually
Infrastructure automation, you know, mining existing data about the infrastructure. What?
Can you speak with details?
Well, my job is to make sure that the application that other developers run, and we create our own platform for that, which is pretty much sounds like a internal in-house platform as a system. And most of the tools that do that are written in Haskell.
I suggest we can offline this a little bit, the details, to allow time for 2 more questions.
Well, it's not a question, basically. I just wanted to highlight, you mentioned reading papers about computer science, and I wanted to highlight this and tell everyone that reading papers is a quite interesting thing, and you can, even if you read papers on computer science or in some other fields, you may not understand everything, but some things are just appear and you can think about interesting new stuff and become better programmers and everything.
Thank you.
So the last question.
I have actually 2 questions. So first, could you please share a little bit about if there are any like big, cool, widely known projects written in Haskell, and if there are like any big guys staying behind the language and the compiler. So if somebody invests time in learning it, he can be sure that in like 10 years or 5 years it will be still in good shape. And the second question is, why did you switch from Erlang to Haskell? So you said that you looked at Erlang, but it didn't suit you. So what was the reason?
Well, I didn't switch entirely, because, you know, I've been waiting for a right moment to employ Erlang in my stuff, but I've been doing pretty much infrastructure automation for the whole year lately, and I've looked at Haskell is pretty much the better tool for the job. But no, I'm not giving up on Erlang. And to answer the first question, cool projects in Erlang, in Haskell. Well, the first thing that the coolest project in Haskell, first and foremost, is the Haskell compiler. Because people, well, pretty much it's pretty hard to, a pretty complex program, but it also inspired all other language designers and implementers to take features out of the language and implement it differently in a more pragmatic way. Like Python took list comprehension from Haskell. C++ tries to take everything from Haskell now, but, you know, twists it in its own way. C#, pretty much Haskell used to be a Microsoft research project, and C# is Microsoft's flagship language, and they're taking a lot of implementation details from it. Same goes for F#, which is like ML on top of .NET, but it still takes lots of ideas from Haskell, like STM, which is a software transactional memory stuff. So for pretty much most of the exciting projects are very deeply in the computer science area, and they're used internally for many stuff like the C# compiler or whatnot. But there are also some pretty cool startups that started to use Haskell. There's a Standard Chartered bank that they don't never speak about what they do about Haskell, but they have pretty cool stuff in it. A lot of people are writing their domain-specific languages, like Barclays Capital, the bank. They are doing DSLs for financial stuff, and Facebook is using Haskell for fighting spam, and Google is using Haskell for doing some infrastructure stuff. There was just rumor about that, but there are a lot more. Come to me, and I'm going to tell you more. Yeah.
Okay, I understand there's an infinite list of, like a lazy Haskell UA list of projects that can go on forever. Thanks, Vova.
Thank you, guys, and have a